Good day, everyone. You're welcome to Born Tutor channel. We are still on variation, and today we'll be talking about partial variation. We can say a quantity varies partially to another quantity. That is, it can vary partly to one quantity and also partly to another quantity. In a case whereby we can have V to varies partly to like W and also partly to, let's say, V. Sorry, we have V already. Let's say varies partly to P, whereby V varies to two other quantities which are W and P. And we can also say a quantity varies partly constant and also partly to another quantity, whereby we can have a case whereby V varies partly constant, let's say A, and also partly to another quantity, let's say W, whereby A is constant whereby A is constant. These are two types of partial variation that we have. So we can say V varies partly to W and also partly to P. Or we can say V varies partly constant and partly varies to W. And we can have an example on this to illustrate this more better. So this is an example on partial variation. It says, suppose C is partly constant and it partly varies to P. Firstly, let's write an expression for that. They say C is partly constant. Let's say the constant is A and also partly varies to P. So we can introduce a constant, and when we introduce a constant, it will be C, sorry, C equals A plus KP, where A and K are constant. Where A and K are constant. This is an expression that truly illustrates what C is partly constant and it partly varies really means. The question now moves forward and says, if the value of C equals 18 when P equals 2 and C equals 23 when P equals 4.5, find the formula connecting C and P. Truly, this is an expression connecting C and P, but we have a lot of undefined and unknown variables there, which means we have to define the constant first before we can call it an equation. So the next thing to do now is to define the equation by getting the value for A and K, which are the constants. And from the question, we're given two values for C and P. That is, when C was 18, P was 2, and when C was 23, P was 45. Since we know that the equation connecting them is C equals A plus KP, which is the constant, we can substitute all these values into this by saying C equals 18 and A is constant plus K is constant, but P is 2. So we can say 2K. We can say 2K. Since P is 2, let this be our equation 1. And we can also have another equation when C equals 23, your A is constant, and your P is 4.5. Let's say 4.5K. And that is our equation 2. Automatically, we've derived into what we call simultaneous equation, which means we'll be solving two equations that has two unknowns at the same time. So the solution now is subtract equation equation 1. Let me use equation 1 from 2. You can use any equation you like. You can subtract equation 2 from 1 or equation 1 from 2. This is just one method of solving simultaneous equation, which is called subtracting method. We have elimination method and we have division method. So this will give you 23 minus 18, which is here, equals to your A minus A and plus your 4K, sorry, 4.5K 4.5k minus 2k. So this will give you 5 to be equals to your a minus a will be 0, and you are left with 4.5k minus 2k will give you 2.5 2.5k. And from this, your k will be equals to 5 divided by 2.5k. Sorry, 5 divided by 2.5, which is equals to what? 2. Your k is equals to 2. So if your k is equals to 2, you can substitute k into any of the equation. Let's say substitute k into equation 1. The reason why we are substituting k into one of the equations is because we have the value for our k now and we need the value of our a. So substituting k into any of this equation makes a the only unknown there, and you will be able to find the answer to your a. So I'm choosing equation 1, which is 18 to be equals to a plus 2k. From this, if I want to make a subject of the formula, your a will be 18 minus 2k. And we already know our k to be 2 also. So you have 18 minus 2 into bracket 2, which is your k, equals to 18 minus 4. And your answer is 14. So therefore, the formula connecting your C and P now is your C to be equals to your A, which is 14, as the value you've gotten, plus your K, which is 2. Then the formula connecting the two is C equals 14 plus 2P. And that is the answer to the first question. Now the second question says, find C when P is 7.5, which means you just have to substitute this 7.5 into the equation here, and you'll be having your C to be equals to 14 plus 2 into bracket 7.5, which your C will be equals to 14 plus 2 times 7.5 should give you 15, and your answer should be 29, which means the answer to your C is 29 when P is 7.5. This is a very good example on partial variation, but let me give you one more example more in the case whereby you can have any other variables varies partly as an inverse of another variable, and also partly either to constant or another variable. So this is another example on partial variation. It says, suppose y varies as the sum of two quantities, one of which varies directly as s and the other inversely with s. See this? That means your y varies to the sum of two quantities, which one varies directly as s, that is direct variation, and inversely as with s rather. So this is how you're going to have it, that is, it varies directly as s and inversely with s. So if you introduce the constant now by eliminating this, you'll be having two constants. Please, you'll be having two constants because x here is one variables on its own, and this x here is another variables on its own, although it is of the same values, but at least they are acting as two different variables here, not just one. Which means your y will be equals to, introduce a constant for this, which is ax, plus another constant for this, which can be, let's say, b over x, which can be b over x, because if you multiply 1 over x by a constant, it will be b by the constant b, it will be b over x. And from here now, you can now start substituting the values that are being given to you for you to be able to derive the equation you will be needing for finding the relationship between y and x. And the first value says when x equals to 6, y equals to 9. Let's start from here. When x equals to 6, y equals to 9, that is y equals to 9, and you have ax, which is x. Sorry, x is 6. We have a6. This is 9. You have a6. Let's say 6a instead of saying a6. 6a plus your b, which is the second constant, is still unknown, b over 6. Let's say that's our first equation. And for the second one, when x equals to 14, y equals to 18, you say 18 equals to 14a plus 14, sorry, b over 14. Let's say that's our equation 2. The equation 1 and 2, I said they are in fraction. And because of that, I don't like working mostly with fraction when I'm solving simultaneous equation. I like to linearize my equation so as to make it easier for me to solve. And if I want to linearize equation 1 now, let me call equation 1 out to be 9 equals 6a plus b over 6. If I want to linearize this, what will I do? I'll multiply each terms I have there by the LCM of their denominator. And the denominator of 9 here is 1. Denominator of 6a here is 1 also. And denominator of b over 6 here is 6. Which means the LCM of all the denominator is 6. So if I multiply each time by 6, this gives me to be 54, because 9 times 6 gives me to be 54, plus 6, equals to 6a times 6 will give me 36a, plus if I multiply 6 by b over 6, I'll be left with b, because 6 will cancel 6. And I'll call this my equation 3. I'll call this my equation 3. So moving to the next equation, which is equation 2. Equation 2 that says 18 equals to 14a plus b over 14. So I'll multiply each terms by the LCM of the denominator also, which will be 18 multiplied by 14 to be 252 to be equals to 14 times 14 will give you 196. Yes, 196a to be equals to, 196a plus b over 14. If you multiply it by 14, you'll be eliminating 14 from there and you'll be left with b. And I'll call this my equation 4. I'll be calling this my equation 4. Please don't get it confused. Your equation 1 is still the same thing as this equation 3. The only thing I did there is I linearized the equation. And your equation 2 also is the same as your equation 4. The only thing I did there also is just that I linearized the equation. Now that I'm having equation 3 and 4 as my reviewed equation 1 and 2, I'll be working with equation 3 and 4 and not equation 1 and 2. With that, I'll be subtracting equation 1 from 2. Hope you remember how we solved the first one. I told you this is a simultaneous equation, solving two equations at the same time. So I'll be subtracting equation 1 from 2, and I'll be having 252 minus 54 to be equals to 196a minus 36a plus b minus b. So if I'm subtracting b minus b, that means I'm eliminating b because it will give me 0. 252 minus 54 will give me 198 to be equals to, this will give me 160a. This will give me 160a. I've eliminated b and I'm left with 198 equals to 160a. So I have to make a substitute of formula for me to find the answer of a, and therefore my a will be 198 over 160. And 2 can go here, 2 goes here, in 160, that's 80. 2 goes in 160, 2 in 18, that's 80, and 2 here goes in 99. Therefore, my A equals 99 over 80. My A equals 99 over 80. Now that I have the value of A to be 99 over 80, I can substitute it into any of the equation I'm having here for me to have the answer. I can substitute it into equation 9. I can substitute it into equation 1, 2, 3, or 4. I can pick any of the equation to substitute my answer. So I'll be picking equation 1 also, since it has the least values for me to be able to do, easy multiplication. So I'll be substituting the value of a into equation 1 for me to get the answer. Substituting it into equation 1, and equation 1 is 9 to be equals to 6a plus b over 6. So that means my 9 equals you have 6 multiplied by 99 over 80 plus b, which I'm looking for, over 6. So this will give me 9 to be equals to 2 here 3, 2 here 4, 40. Yes, 2 here 40. So I'll be having 3 multiplied by 99 over 40 plus b over 6. So I'll be having 9 to be equals to 3 times 99 will give me 297, yes, over 40 plus b over 6. I'll be multiplying through by the LCM of the denominator. The LCM of the denominator, I'll be choosing 120 because 40 goes in 120 and 6 also goes in 120. So that would be 120 into bracket 9 to be equals to 120 into bracket 297 over 40 plus b over 6 into bracket 120. So b here 1, b here goes, sorry, 6 here 1, 6 here goes in 20. 40 here 1, 40 goes here in 3. And 120 times 9 will give us 1080 to be equals to, which is 1080 to be equals to 3 times 297. That will be 891 plus 20b. So I'll be having 20b to be equals to 1080 minus 891, and my b is, sorry, and my 20b is equals to 891. 1080 minus 891 will give us 189. Therefore my b will be equals to 189 over 20. So therefore the formula connecting the y and x will be equals to y to be equals to a, my a is 99 over 80 plus, that was 189 over 20x, which will be our final answer. Thank you for watching this video from the beginning. Please don't forget to subscribe and like this video, on your notification bell, and if you have any question on partial variation, you can drop it in the comment section below. Thank you very much. Have a wonderful day.